he knows what the video session is that he's looking at. So I've done my job. My only other job is I'm going to pass out tickets that you can take up to the vendor area upstairs for dinner tonight, put in the jars and make sure you only put half of it in the jar. One of it says, keep this coupon. There's been some confusion. If you put both in, it's not going to do you any good. Put one in so you have a number, okay? All right. Take it away.
Cool. Do you want to say anything? Go ahead.
I just want to, hey, my name's Nathan Fichetti. I'm with CVE Technologies Group. We are first year here as a Diamond partner, so thank you for having us be part of your great event here. Just in case you don't know, we're here at the OpenDNS presentation. Recently, as we all know, Cisco acquired OpenDNS. Since that acquisition has gone through, obviously it's been a really positive thing. We've been working with a lot of the school districts in Oregon on OpenDNS projects. It seems like it's going really well, so we thought this would be the perfect venue to bring you guys in and give you a little bit of an update on kind of what's going on with that and everything else. So thank you again, and let me know if there's anything we can do. Come by our booth. We got plenty of chips for you at our booth this evening. I'm sure we'll be handing those out left and right. So thanks again, you guys.
Cool.
Jordan?
Thank you. If I can find this. There we go. Perfect. So, Jordan Jakowski, I'm not a Diamond sponsor. All I have is stickers. Do you want to open?
You got this, though.
Working in education, I think everybody knows the motivating value of a sticker. So, I got a couple. Not for everyone, though, all right? So, I was playing around when I was sitting over there in the bar area. So I went in and I used a tool called Graffiti that OpenDNS owns. It's open source, completely free. The data, it's not free. You got to bring your own data. But I went through, I mapped out every domain that touches ACPEnw.org. And there's actually nothing malicious touching it. So it's kind of fun. I'll do it with a lot of my customers, and you see all kinds of grungy little domains that are like 2 hops away from where they're hosted and stuff like that. So I'm an engineer. I'm not a sales guy. I feel really bad that I have to PowerPoint today, so I'll do my best, but it's not my natural habitat. I call this my so what slide. I'll probably have to stop using it eventually, but so far, like, I use it to kind of answer the question, okay, Cisco paid $635 million for OpenDNS. We're like a 200 and something person company. Like, what was so cool about what we did that was different? We are the second largest recursive DNS provider in North America. Google is the only organization in the world that sees more DNS traffic than we do. We see about 80 billion DNS requests a day, which sounds like a lot, and it is, but it's about 2.5% of all the internet traffic, or all the DNS requests, not all internet traffic, obviously. 65 million business and home users. 65 million home users the home users are a big chunk of that. I don't know, anybody with show of hands, OpenDNS home users in here? Okay, so very similar concept when you use the enterprise product. Of that 65 million, we've got about 15,000 commercial, education, corporate enterprise, whatever you want to call it, customers. 100% uptime since 2006. We've got 25 data centers worldwide. The guarantee is 5 nines, but we've never had an outage, so I'm pretty confident that you can't take all 25 data centers off at the same time. And yeah, we do. So basically, we're using DNS to do security, filtering. Can I get to malware.com? Yeah, here's an IP address. It's the wrong IP address, but I'll go ahead and fulfill that request for you and land you somewhere else. And in doing so, we can do that filtering with 0 latency. You're using DNS anyway. It's already there. It's already in the stack. It's not a change to your environment. It's not disruptive. And it's cool. You can use it on any device. Device you don't own, you don't have to put an agent on it. It's on your network. It uses your DNS. It gets a policy applied to it. And that's what we're trying to do. We're trying to do it, we think, a little bit differently, and any port, any protocol, any application, right? Anything that uses DNS will get hit with our service. It's not restricted to just web, FTP, HTTPS, things like that. And then we take all that data. One of the security, or one of the sales guys I work with, his funny joke for all customers is, we're just like Google, except we use the data for security instead of advertising. Right? We don't sell your data. We don't do anything with the data, but we do data mine those 80 billion DNS requests a day. This visualization that I had up is basically what I did. I said, okay, do 6 degrees of Kevin Bacon for a domain, and then find the bad ones. If I take a list of 100 malicious domains, I dump them into our engine on the back end, I'll immediately see all the domains that touch those domains. I'll see the registrar address that registered that bad domain, every other domain that that person has registered. I have some examples that are just spectacular. You know, single email address has registered 1,200 domains. They're all malicious. Every single one of them is used for phishing, you know, things like that. So we find a little string of the bad guy's architecture, and we start tugging at it. And that's what we, once I've mapped out the bad guy's infrastructure and architecture, it makes it easier for me to continue to block anything new that they spin up. And I'm going to show an example using ransomware in here in a minute. So, cool part, you can do it, you can deploy it, like if you just want to do one site, it takes you a couple minutes to deploy it. I rolled it out for a 250,000 person company in the petroleum business, took a half hour, right? The change control and the planning was obviously a little more than a half hour. But we opened a change control window, cut over the DNS, marked the change control as completed, and we were done. That was a Friday afternoon, right? Easy peasy. So less time cost, cleaning compromised devices. I don't know how many of you guys, we call it Malware Monday, right? One of the cool things we can do is we do have an optional agent that goes on the device. So when it's off network, we can still enforce DNS against it. So you have a user that's sitting at home, letting their kids play flash games on a device that, you know, the school district owns. Gee, I wonder how you got infected with something, you know. So we can still push that security bubble out to that device by controlling just its DNS when it's not on the network. You're not forcing it to VPN back in, right? It makes it really easy to do. And there's some, I was talking to somebody earlier today about, you know, you can choose not to log things when that person's off network. You can choose to enforce a completely different policy when they're off network. Do you want to let them surf social media, right? Do you want them to get to, say, like Netflix? Well, maybe you're not supposed to sit there and watch Netflix all day long when you're at work, but when you're at home, I really don't care. When you're here at the resort in your hotel room, I don't care what you do. We can have a different policy for that. I still don't want you to go to malware. And I get visibility in everything you did. And if you guys chase a compliance game, it satisfies that requirement as well. So like I said, less than 5 minutes to deploy. You basically go in, and if I have time, I'll show you a live demo. It's much more exciting. You register your egress IP address, give it a name. Like in this case, it's London, New York, San Francisco, and Sydney. They could be individual schools. They could be individual districts. They could be, you know, whatever. If you have an egress IP address, place that in there, and then you select the policy. These ones just all have the default policy. But really, that's at the basic kind of bottom level of the pyramid. That's all you need to do to deploy it. Now it can get more complicated if I'm not gonna put you on the spot.
Don't let thunder at the end.
But he might have a much more complicated deployment strategy. I'm not naming names.
Jeremy.
So yeah, it's two products. I would say 80% of our business is in what we call umbrella, the blocking, the defeating malware, containment strategy type stuff. The other piece of it is what we call investigate, which is we say, hey, we have 80 billion DNS requests a day that we keep, and we've been keeping them since 2006. A lot of people in the incident response space will say, oh, how do I get access to that data? How do I get access to that information? So we have an incident response tool. Obviously, it's anonymized. But you can put a domain in there and say, okay, 65 million people in 130 different countries using this service, how many of them have made requests to this domain? How many requests does this domain get on an hourly basis? Where's this domain at? What's the breakdown and distribution of the people who are trying to visit that domain? You can go in there and pull all that information out. We'll show this is why we think it's bad. This is what botnet's being hosted on it. All that information is out there and available in the Investigate portal. And this is kind of this is the idea. And this goes really well in, you know, why did Cisco acquire us? Why would I use OpenDNS? You know, kind of how does this fit into my overall strategy? You do defense in depth, right? I think everybody, it used to be like some people weren't, but I'd say everybody you know, it used to be, well, I got a firewall and antivirus, and that's my security strategy. Right now, I'm anything else. Nowadays, I think everybody has a couple more tools in the box. They got a SIM. They got some sort of advanced malware protection. You know, you get a malware sandbox, a commercial one. Maybe you built a Cuckoo box and you're rolling your own. But people are looking at other ways. Can I intercept that data? Can I inspect it a little more closely? Can I get information out of it? You know, can I make decisions faster? Can I protect my users? And then on the endpoint, you know, you have your last line of defense, probably with a handful of different endpoint tools. And then, you know, at your big data center and your perimeter, you might have a thicker stack than you do at a small branch office or someplace. So our idea is, what if I could also do it here? What if I could block that request from ever being fulfilled at the DNS layer? Before I've even identified the service, before I've even made a request to the firewall, hey, can I get to malware.com? No. And that's the end of it. And then what does that do to reduce the workload on all of these boxes that you've been investing in and, you know, going out there with your little paring scissors and grooming them and keeping them alive, you know. I don't know how many proxies I've seen that run at like 80% during off-peak hours, right? If I could decrease the load on that. I joke around, one of my sales reps I work with is Canadian. He clears customs in Vancouver. So he's at the airport, he walks up, guy in a little blue suit says, welcome to the United States of America, what's the purpose of your business? Or what's the purpose of your travel? He says business, he says, okay, welcome to the United States. And he's like, hey, there's a Tim Hortons right there, I'm not in the United States. But if they're gonna exclude him from the country, and they should some days, they're gonna do it in Vancouver, right? So they're gonna keep him out at the farthest point from the United States that they can, rather than flying him all the way to San Francisco, putting him on a plane and sending him back. Same concept. You know, like I said, I'm an engineer. We're not going to catch everything. Defense in depth is a strategy, right? If I can put a tool in place and I can intercept a good chunk of that, awesome. I'm better off for it and I can concentrate on these other problems. So using crypto, I think I actually have I think it's Tesla Crypt in here. I don't know how. I don't want to put anybody on the spot. Anybody been hit with ransomware in their office? Sorry. It's kind of a pain, you know. You get really good at testing your backups. Or finding Bitcoins, one of the two. My mom called me, what's a Bitcoin? I'm like, what are you talking about? Well, they said I got to give them a Bitcoin to get my files back. I'm like, just unplug your computer. I'll come over tomorrow. Don't pay them. Just don't pay them. And I just use this because it's you know, a couple people in the room. Thank you, brave enough to raise your hand. My mom, you know. This is very disruptive. It's not, you know, it's not the APT. It's not the Chinese government coming to get you, but it will be disruptive. If I crypto lockered a school district a week before the end of the semester, I could probably disrupt a lot of things, right? And that's just if I was a jerk, not necessarily trying to make money. So this is a cool little, our research group put this together. Of all the major crypto X variants that are out there right now, only one doesn't use DNS on a regular basis. And only one uses direct to IP, right? Two of them use Tor as part of their command and control and encryption. Three of them use Tor, sorry if you guys can't see it over there. Three of them use Tor for the payment portion of it, but not for the actual infection and command and control, right? So Key Ranger is actually pretty cool. It's the one that infects Macs via JavaScript. I have some samples of that. So we're gonna look at Locky. So this is what it looks like. It gives you nice instructions, a couple links right there. 1 Bitcoin, so about $422. I've seen all kinds. You can look it up. I don't believe anybody, but this business is in the billions, right? When you look at what motivates somebody to do this. I mean, when I was a kid, I may have experimented with some computers for fun, but I mean, this is, you want to attract organized crime into this business, offer them $1 billion a year, right? But it's actually kind of fun. I mean, some people are like, oh yeah, I know about ransomware. Like, have you ever actually seen it? Like, have you seen what it looks like when it pops up on the screen? Question? No? So this is what it looks like in Investigate. That's the UI. So the UI, we have an API as well that you can pull this information out of. But But when I looked at gslynda.com, we just know it's a dropper. We don't like it. There's some characteristics that we don't like about it. If you look at the traffic pattern, it was getting, 15, 20, sorry, make sure you guys can see, 15 or 20 hits an hour for the first part of March. So this is about a month old. It's still pretty fresh. But if you look here, there was a significant spike in traffic going to that domain. Not overwhelming, it didn't go like into the thousands. So we started blocking it as malware very generically on the 15th. And then on the 18th, you can see there was an actual sample of an executable that we could associate with the domain. So if I go and I look at this, now Open Graffiti is, like I said, it's a free tool. You can go download it, play with it, and stuff like that. I will caution you, it is kind of a developer tool. It's not the easiest thing to use, but it's free. But I have a Python script that basically goes out into the Investigate API, pulls all the characteristics of a domain in there. So we took gslynda, dropped it in there, and you can see here's a hash being hosted on that right there. Here's more hashes that are like kind of 1 degree of Kevin Bacon away from it. But you can see real quickly, this domain is hosting these hashes, is also associated with this domain, which is hosting this executable, this executable, this executable. And these are ones that we already have categorized as malicious as of, I think this was done on March 18th because we already knew about the executable. But you can see there's these 4 domains in very close proximity to each other. And then there's the name server that's hosting them. There's the hashes. There's the email address that was used to register. You see it was registered to both of those domains and several other ones above it that are off the screen. Co-occurrence. So when we look at those 80 billion DNS requests a day, what did a person request plus or minus 5 milliseconds of each other? So nearly exactly the same time, right? Go to Google, click the link. It's going to be long enough that it's not a co-occurring domain. We might say that Google's related to a lot of stuff, but it doesn't happen at exactly the same moment in time, right? These 2 domains happen within 5 milliseconds of each other. So when I click a link, I might get HTTP redirected several times to a malicious payload, something like that. So you can see there's a co-occurrence, 100% co-occurrence. Sometimes I've seen one where it's 25%, 25%, 25%, 25%. Bad guy's got a rotator. If I can get you to one of those 4 more than once, I'll probably get you to my payload, but I don't want my payload being too noticeable, right? And then these are additional ones that also co-occur. They don't co-occur with each other like these 2 do, but they're obviously related to the same threat actor. So then, like I say, we can start building a picture, and I can start saying kind of guilt by association, right? I'm not saying you're a criminal. I'm saying all your neighbors are criminals, and I'm not going to leave my car parked in front of your house. Perfectly nice guy. Not going to go there. Right? I'm not going to click on your link. So if we drill into just this one, you can start to kind of see the infection chain. And like I already pointed out, here's shared IP address, shared email address, and I can use any of those kind of as information points to start building a profile about the bag. I can use a bunch of other ones as well. This goes into the kind of before, during, and after. Here's the infection point, here's a redirect point, and here's like the follow-on attacks and the check-in and the command and control that are all related. So here is Threat Grid. I don't know if you guys are familiar with Threat Grid from Cisco. It's a cloud-based malware examination. It's not a sandbox. They call it like a glove box where it's not using VMs and stuff to monitor. It monitors everything from the outside, lets the malware fire, and then sees what it does. And you can actually interact with it. So I'll get Dridex samples all the time out of like my junk mail folder, throw them in there, and you wait till Word pops up, and it pops up and says, hey, you need to enable macros. So you can just go, you can interact with the piece of malware while it's on the VM and say, okay, I love macros, man, enable those suckers. And then it starts phoning home, and you harvest all that data. So here's, and this is kind of blurry, but you can see all the country codes. You can see what service it uses. You can see the file names that it spawns. But they're all associated with the sample. So this was submitted to VirusTotal on the 18th of March. There's supposed to be a second slide in there. Apologize, I took out. So the second slide is the submission to ThreatGrid. So we had a sample in ThreatGrid on the 16th. OpenDNS was blocking on the 15th. It didn't hit VirusTotal publicly until the 18th. Looking at Umbrella, this kind of drills into compliance piece of it. So protect all devices that leave your network. Talk about that a little bit. Obviously faculty, devices that are owned by the district, stuff like that. I don't know if you issue devices to students and you want to monitor them when you're off network, or if you have like a lot of BYOD, you're kind of stuck, well, at least I can monitor them when they're on network. 67 categories, and obviously you can create your own block pages. Talk about deploying it, super easy to deploy. And then reduce that remediation time. Chasing something down, I know exactly where that infection is coming from, and I can even match up the username. So that's, let's see, how much time do I have? Plenty of time, cool, let's do a demo. Demos are always better. And actually, let me just, wow. Anybody got a box of resolution? Okay. Let's see. Let's see if we can do this. There we go. Let's see if I can mirror this real quick. All right, so when you log in, this is kind of what you see. It just gives you a real nice overview. I call, pretty pictures for managers and small children. As a security practitioner, the cool thing I like is I can see like this huge chunk of so we break security up into malware, like containment and prevention. So these would be all prevents. These are new pieces of malware that somebody was stopped from going and visiting. The containment would be, these are infected machines that are on your network trying to get out to command and control. You probably want to go turn those ones off, or at least isolate them on the network and maybe see what else they want to do. Depends on what it's, if it's, oh look, you got Zeus, F disk, right? But maybe you do some forensics depending on what it is. So these are all interactive, so I can just click on this and say, okay, show me everything in there, nothing there. So I can go in and I can see, oh, hey, I'm on the internet. Not having internet slows down all cloud-based applications. There we go. There's all the malware. All right, so so in this is a nice, perfect, clean, awesome demo environment. So I have everybody's username, their internal IP address, and their external IP address. In a real world, you might not see all of that. If the device isn't part of Active Directory, right? If your printer starts beaconing out to some host in China, I might only see the IP address. I see the internal IP address. Having the internal IP address is pretty cool because I can make policies based on IP range, and I can have those IP range-based ones supersede the individual user. So I can say, no machine in the DMZ can surf webmail. Because I don't know who oh, you're a domain admin? Big deal. You're not going to surf Gmail from a production server. What are you talking about, right? So you can kind of have that tiered approach to it and dig into it. You can do your regular activity searches for, kind of your regular thing. I don't know who Edith Ham is, but I always pick on her for my demos. So I can do a user-based report where I just go in and I say, okay, show me everything.
You're just showing security on there.
Yeah, I was going to switch over to regular activity to full. So here's full user activity. So I can say, here's Edith Ham. Here's everything that Edith Ham did on the internet, right? And then I can say, since we're talking about content filtering, Edith, why are you surfing porn? So, there's, everybody, so Catherine, Robert, Cliff, Jose, Willie, those people are all surfing porn. You're all going to get fired. I'm going to send this report to HR, right? So you can do your regular, and I can go back, and I honestly, I used to run the IT security investigations program at Intel, and I hated, I used to have this huge, like, 72-point font PowerPoint presentation I'd do. Like, pornography is not a security problem. I mean, it's the performance problem, obviously. But please don't call me and take up a week of my time to look into pornography thing. But I can go back 7 days, so I can put a user in there and say, show me everything they've done for the last month. We have the ability to go in here, and if you want to, since we're cloud-based, we use AWS. So we put all the logs in AWS, and then you can like pull those down, drop them in your SIM. So a really interesting discussion I like to have with people is, like, do you currently have access to all of your global DNS logs? Like, if somebody said, hey, how many people went to this domain and clicked on this phishing link? How long is that information gathering process generally take you? Is that an easy task to fulfill, or is that like, oh my God, grep, is it a big long task? If you have a SIM, like I use Splunk as an example, not that I'm a proponent of Splunk. Is Splunk a sponsor? Okay. But they have an S3 app. So you dump the logs in S3, you download the S3 app for Splunk, which is free, and you point it at the bucket that you created, and then all of a sudden your logs are in your SIM. It's like literally that easy. So you can also pull it down. I have a little Python script. I don't know what I'm doing with Python, so you guys could probably write a better one. But it goes out to the AWS bucket. Is there anything in the AWS bucket? If so, copy to a local directory. Once I've confirmed that it copied, delete it out of the bucket. And so you can use like a free AWS bucket and just use it as transitory. Just empty it out as fast as it fills up. So it's just easy for us to take everything from all the logs from our data center, dump them into an AWS infrastructure that you own. We don't provide this to you. You just go and create it. And then they're your logs. They're encrypted. They're behind something that you control, and you can pull them down. What other cool things? Integrations. So the enforcement API, we have a bunch of out-of-the-box integrations. So like Cisco Threat Grid. So any piece of malware that you put in Threat Grid and it detonates, and then it says, hey, this piece of malware tries to talk to all these domains, you can automatically have it block those domains. Or if you're getting lists of intelligence from other sources, you can dump them in there. I jokingly say, like, somebody has like a CSV of bad domains, and that person comes in on Monday morning and copies and pastes it into an ACL list on a firewall. And it's a horrible job, and it probably crushes your soul every time you have to go and do it on every Monday morning. So you could just automate it with an API. And, automate yourself out of a job if you possibly can, right? So just take all, you're getting threat intelligence from several locations, dump it all up in here. You have content filtering categories that are specific to, academics. Dump it all in there. Use the API. If you go to docs.opendns.com, completely wide open, go developers, API documentation. There's code examples for like Python, PHP, Perl. It's all out there. Just use it however you want. Obviously, you have to be a customer. But the documentation to figure out how to do it it's all really straightforward. If you're, I work for Cisco now, but hey, whatever. If you're a FireEye customer, same thing like Threat Grid. Threat Grid's super easy. You go like you log in, you go to my account, you copy your API key, you paste it in here. Within a couple of minutes, you'll see all these domains showing up that are all malicious or related to other malicious samples and stuff like that. We have a safeguard in there, like you can't. A lot of malware tries to go to google.com and then tries to go to whatismyipaddress.com and then tries to go to like a drop zone and get more tools. You can't blacklist Google. Right? We have some catches in there. Like if it's like in the Alexa top 10,000, you can't accidentally block it. Same thing with FireEye. If you're a FireEye customer, you can take any domain that FireEye sees in a sample and block it automatically on the fly. You strip something off email at 3 o'clock in the morning, send it over to FireEye. FireEye says, hey, this is malicious, and it tries to talk to these domains. It'll send those up into the cloud, and you'll be blocking those before a human comes in, interacts with it, touches it. The person doesn't need to be VPN'd in. I usually use the example. So my cheap shot at FireEye is they're really expensive. So say you only have FireEye NX Appliance at your main data center, but you have other egress points within the school district. I I can push that protection from that single device out to all of my egress points, and I'm going to do it via DNS. I can push it out to every user who's sitting here on Wi-Fi on their laptop with the agent installed, but I don't have to buy FireEye appliances for it. So basically, I turn FireEye into a blocking mechanism, and I use DNS to do the blocking. And it's super lightweight, and it's super fast. Doesn't have to be inline, doesn't even have to physically be there. Let's see. Any questions? We're at 3:15. The multi-org console, I'll show you that a little bit. It allows you to break, now I have these broken up by like Brazil, Canada, EMEA, manufacturing, research, have been very corporate-y sounding names, but you could take an entire district, chop those up by school, parcel out the number of seats, and charge back by school. You have 5,000 students, you only have 150 students, and you can break it up that way, and even push the delegation of the creation and management of the policies down to another person. Kind of depending on, whether you have IT staff that wants to do that, or certain competency level, or you have a local hero that wants to do it. You're like, hey man, knock yourself out. Please do my job for me. I have plenty to do, right? Yeah. So then that pushes it down. So we're talking, an elementary school might have different needs, have a different policy than high school. Right? I was talking to higher education. The dormitory filtering policy is complete. 19-year-old kids playing World of Warcraft until 3 o'clock in the morning, not doing their homework. Completely different use case than a research network on a higher education campus. Yeah, it allows you to manage all the orgs. This used to be dirty little secret. This was what we called managed security, or for like MSPs. So partners would purchase this, and then they would, like kind of SMB business, right? Hey, you're a law firm that only has 20 employees. You do not have a IT security staff. You got the IT person, right? So they could manage this for them and just push down, okay, you got 100 employees, here's 100 employees, I'll manage your policy, I'll alert you when something bad happens. And so we basically just converted that over, so regular customers can chop these organizations up by license, by location, delegate all that admin out, have their own reporting and stuff. Yeah, questions? A lot different than the home version, right?
Well, speaking of that, can people get the more enterprise version on a demo?
Mm-hmm.
Can you set up, how's that work?
Oh wait, let me,
So if a school district or an ESD wants to do a trial, how does that work?
So yeah, obviously they could go through a partner.
Preferably. Be my first choice.
Yeah. There's several here to choose from. I'm not picking, I'm not picking sides. The Cisco team, so if you have a strong relationship with your Cisco rep, talk to them as well. Because I cover 12 states. I'm local to Portland, so that's helpful, but I cover Western Canada, Alaska, Hawaii, the Pacific Northwest, the Rockies, except for I cover everything in the West except for California and Arizona. So I fly around a little bit. Casey Guillory in San Francisco is dedicated education account manager. So if you want to take a picture or just get with me later, but it's Casey@OpenDNS.com. Easy.
Really good guy.
I'm Jordan@OpenDNS.com. Another easy one. I have a Cisco address, but it's JGACKOWS@Cisco.com. I can't even remember it most of the time. Yeah, so this is actually, so I've been an SE for a long time. This is the first job I've had where the account manager starts the POC. So if you want to evaluate it, the sales guy's like, yeah, no problem. Boom, you get an email and you start and you're off and running. Generally, if you want to do it, get involved with Casey, and there's a guy named Sam Wortham who's kind of my counterpart, probably does 80% of his work with Sam. Great guy. He actually came from Cisco, from the CWS side of the house, and came over to OpenDNS like a week after the acquisition. I think he was kind of already talking to us about coming over, and great guy. He'll sit down, hey, okay, what are you trying to accomplish? Let's come up with a project plan. Okay, in the next 30 days, what do we need to see for you to call this a success? And help you kind of go through and measure the success of the project and get metrics and stuff behind it. Yeah.
Or you can just get my business card and I'll...
There you go. There you go.
So we'll be there tonight. And one of the things too, we all, and in his business, I mean, it's good to come to these presentations, you hear a lot about it, but I think the proof is usually in the pudding. We've recently gone with a project. We did a fairly large OpenDNS project with the Clackamas ESD. Jeremy Pietzel was the one that spearheaded that, was the big driver behind that. I mean, most of you guys know him here. I'm sure he'd be more than happy to kind of share his experiences and the reasons why he went from, I think you were using IronPort originally, and then you and I started talking about this. Actually, wasn't it even right before Cisco even bought him? You were asking me about OpenDNS? Like, yeah, go ahead. Come on up. Kind of talk a little bit.
Have your mic.
This piece.
So the camera cracking. Look at that.
So this wasn't really planned, so it's kind of the spur of the moment.
Extemporaneous, man.
But we got together with Portland Public Schools last year and Multnomah ESD and Northwest Regional ESD. A couple of us to figure out how to do filtering. Web filtering is becoming a bigger and bigger issue. We push a lot of bandwidth as big agencies, and doing the normal traditional web filtering through a proxy system was just not cutting it, right? And so what do we do? And so last year there were some presentations on NX filter. OpenDNS is very similar to that. It's a paid version, so it's a, it does cost some money. But one of the things that we were running into was with our IronPort systems, which we really liked, was it was just, we're having to spin more up. Last fall I had to spin 10 more virtualization VMs up to be able to handle it. I was running 17 of them to be able to handle our traffic and constantly not seeing an end to that. With this system I'm able to, it's all up in the cloud. I don't have the physical hardware, and I put in some virtual appliances. And so we spin up some virtual appliances inside our networks for our districts that all the DNS requests go to that and then goes out to OpenDNS. And then the reason there is so that we can, so it's a little bit more complicated than what he was showing in his presentation. It does take a little bit more than 2 minutes, and it takes some planning. You want to do it right. But in the process, we're able to identify those local internal IP address spaces that then we can then pinpoint back to who's doing what. But after doing this, Clackamas ESD, we have 10 plus school districts going through it. Actually really being able to roll out and change from one system to another in about an hour if the people we're working with on the other side of the phone, and how to change your DNS. We go in there and we have everyone change their DNS to point to the internal OpenDNS VAs, and then change DHCP to have all the DHCP to hand out the OpenDNS virtual appliances IP address space, and then go into the firewall and block UDP 53 from everything, so that people can't just bypass the filters. One thing I do is go in there and I monitor what devices are still using other devices to see who's going to break and pre-warn the school districts. I have a few of my school districts in here that these devices are going to break when we make this change, and to go ahead and make those changes ahead of time, because we do want to block UDP 53. Another great thing you didn't mention was before in our proxy system we were using WCCP load balancing across these things. I do not have to now have a box there that everybody has to go through to be able to load balance across all these multiple proxy servers. The other thing is we're filtering not just on port 80 and 443 on a proxy on a stick. We're doing all 65,000 ports, and so that's a huge benefit in this as well. Pretty instantaneous when, I won't name names of districts, but we started seeing botnet attacks happening that start and last for 6 hours and shut down for 28 days and start again, and these things going out. And we're now blocking. We never saw those before because they were using random ports and these type of things. The malware attempts that were coming on. So as you know, I set up the network here, ACPE, and so I got Cisco's permission to add the ACP to go through the filter. I'm not filtering you guys for anything except security. But it's kind of
see what you're doing.
Yeah, I can see the porn sites and the game sites that are happening, and you know, those type of things. But logging those things and seeing what they are, and as you were mentioning, you know, you can spit those things out if you have an AWS account. You know, we're currently not doing that.
I mean, you can do, yeah, you can do, like, if I just need a CSV of a bunch of data, I can schedule that and I'll get a huge file. I think it stops like 1 million lines or something like that. So you can get a pretty huge list of, you know, visits, but if you want to automatically do it.
So in the past, when people needed to bypass the filter, say you had legitimate reasons, usually it's the vice principal of a school, usually high schools, that really want to bypass that filter, be able to know what you know, student Johnny was doing or that type of thing. No longer bypass the filters anymore in that same, you know, aspect of, you know, going through that proxy server. We still have them go through the system, but I write a different rule set for them, and I still filter against that security threat aspect of things. That also allows me to be able to report and log on what those people are doing as well. So in case their machines were infected, or, you know, they needed that IP number to be bypassed, but they weren't doing, you know, the nicest of things themselves, you know, during the day on that system. So we have the multi-org console. It was kind of edited and changed for ESD type environments, so that I'm able to then kind of break out my districts and report differently on that. It's been really nice. We have another district. We have, we were talking about in the last session a little bit, the DDoS attack. Everyone's had a DDoS attack, probably. We had some last year, and you're always fighting this and how to do it. Now, we were able to then pinpoint down to not the student necessarily, but in a building where it was originating from. It happened to be a middle school student, and just during testing time. You know, they can do those for free and generate the mass amount of bandwidth that doesn't overload our links, but overloads our firewalls. Or before, in our proxy system, they're always attacking our proxies, right? And this allows us to get more granular and not just affect everyone because of a proxy. It gets down to that building or that particular IP number. So
How big are your pipes that you're trying to scale up to with the airports?
Well, we have about 40 gigs of bandwidth available. Not using that all the time. It allows for us to peak up there. But, you know, if you've got a firewall that can only handle 5 gigs.
Right, and you're sustained at 10, or 25% of your pipes sustain, and you, like at lunchtime, you peak.
The firewall, you know, blocks that. But so those are some kind of real-world experiences. Any questions?
Yeah, got some time. Yeah, Jeremy up here.
Can you get to the student level now? I mean, can you find out the student, is it work with AD? Or?
Yeah, so I haven't implemented the AD structure of that yet, because not everything is on AD. And honestly, I'm trying to roll out of a system very quickly before the licenses die on that and stops filtering to get onto another, the OpenDNS system. It does take more than 2 minutes in a bigger environment.
You're filtering. You don't have your VAs.
So I have a little bit over 50 VAs in our environment built up, but that is the next step that we'll be looking into. They also have agents we haven't deployed yet that can go on to, you know, your Windows machines, but they don't do all machines. And one request I would ask is, can you get a Chrome extension, Chromebook? I know Portland Public. I don't know if Portland Public's in here, but you know, we've teamed up against OpenDNS to make sure that that happens, because all of us have Chromebooks and we want to send those out, right? And so OpenDNS doesn't have that. And according to them, it's not necessarily all the restrictions from OpenDNS, but actually Google themselves. So.
Yeah, so this actually, the question I have is kind of what you're saying right there. We get, there's kind of 3 scenarios that we deal with. There's we want to just protect everyone. So that big blanket, when I see that graphic go up there, it makes me feel good. I mean, that's the reality there. It's like, so there's that aspect, and that looks great. I think that's really awesome. The second aspect is on the reporting side, and it's it's obvious you're tracking that data, which is really wonderful. And then, so then it's how to access that. And I know how we interface with it is we'll get a call from a principal or from an administrator that's, or an email or a ticket that says, I would like to know what Johnny was doing between this time to this time on his whatever device. Or sometimes it's for an employee for an HR request or something more to the effect of that. And so right now it's a little bit challenging for us, especially if they've gone in and tried to hide that information, for us to be able to easily pull that information and present it to them to fulfill that request. And so that's a value that we're looking for. Is this?
Sure. Yeah, we're fairly new into the system, and I'm trying to roll over, you know, a lot of school districts and a lot of stuff to get in there. One of the things that we're doing is we're extending our lease times now. So during the changeover, I brought everyone down to an hour so we could change them over. But now we're extending those lease times even up to 30 days or more, so that when people get on, they always get that same IP number. So it gives us a little bit more time to track devices through the logs that they have, because I'm looking at the internal IP address, because I'm not able to get necessarily that name of that machine or that name of Johnny, but there's other mechanisms outside of OpenDNS that we can put our detective hats on and use that information to find what we need to find.
Clarify the image that you showed on the screen where you were able to bring up a person. Is that through the client aspect?
No, it's through the Active Directory integration. So the virtual appliance,
Okay.
so the virtual appliance he was talking about, excellent explanation, by the way. Some people don't get it at all. So like you said, you advertise that, hey, here's your DNS server IP address. It's a virtual appliance that we have on your network, right? Request hits that. If it's going internal, it just says go inside. Go ahead and figure out where mail.schooldistrict.com, let's go that way. If it's outside, it sends it outside. It sends it up to us. But it changes the DNS request into an eDNS request, and it pads on the internal non-routable RFC1918 address, right? So it's, all it does is it makes it, 160 bytes, right? It's tiny. Sends that out, resolves it, sends it back. Oh, you want to go to Google? We let you go to Google. Everything's fine. The Active Directory integration synchronizes, this is the IP address that requested it, here's the user that has that IP address, and it sends both pieces of data in that same eDNS request and sends it up. So the device, the user on the device has to be logged into Active Directory for us to get that information. So that's why I said in a perfect world, everything looks just like my demo. Realistically, if you have BYOD and you're just letting people jump on the Wi-Fi, you're probably not going to be able to force that, unless you're forcing them to also then authenticate using some sort of credentials. You're going to see the IP address, and maybe no username.
Yeah,
and you'll get that,
It doesn't work with all devices. And in education, we're device agnostic, right? And so it's not going to work 100% of that time.
But
So.
a Chrome extension, that's
No, you're not the first person.
So let's all chant Chrome extension. We're gonna. He's not leaving without knowing that, right? Mark from PPS in here. He'll tackle you on the way out.
Product manager on the phone.
That's right. Because it's going to take a group like this to make sure things change, right? And so
I
it's.
don't know if that's Google. Like if Google doesn't allow an extension on Chromebook to hijack the DNS settings, or if there's another reason.
Yeah.
Right one.
Did you have
support it?
a question or? Oh, okay.
Force us to. Yeah.
Are you guys doing any kind of decryption?
No, we're not. So I would say the drawback to it. So, like if you're replacing a proxy with this, you can do that. I also know a lot of people, they keep their proxy for some purposes, and then they add DNS on top of it. We're not inspecting the inside of the content at all.
So when you're looking at logs and stuff, you can't see what little Johnny's actually done Google searches for? Is that correct?
You just enforce safe search at the DNS level. There's we're not looking at the content. We're not downloading the executable and looking at it. So if it's HTTPS, we don't care. We're still going to block it.
Right. Yeah.
If it's SSH, we don't care. We're still going to block it.
And that's what's the beauty of it for me, because in my iron ports, as everyone's going over to HTTPS and not necessarily creating their websites to spec, a lot of them are being blocked inadvertently, and so always having to go in there. I mean, I have a couple of my districts know, because they're always sending me the emails, hey, this is blocked, it's just a water purifying system or whatever, and being able to do that. One thing about safe search, the way to enforce safe search, because OpenDNS does not change that to a force safe search header. It's just the same way we've been doing it before. So as one of the domains, for instance, I'll use North Clackamas as an example. I send North Clackamas inclack.k12.org.us saying this is an internal domain. So it just goes to its internal DNS servers. I also put in there, say, hey, here's www.google.com. And in there, in DNS, you put in the D record of, for safe search, and then it then gives out the correct information. I then take that DNS server, I point it back to the OpenDNS VAs, so that if anyone was pointing to that DNS server, they would still be filtered and inspected. And I encourage, all your servers and these type of things to point to those OpenDNS VAs and not just your AD server, because if it does get hacked, then the reports will show the actual box that is infected or having an issue versus just your internal DNS server, because, it's very hard to find it then. So.
Answer to the question. All right. Well, thank you guys for your time. Feel free to stop by our booth tonight. Appreciate your. Oh, go ahead.
I had one question. Does anyone have or paying for OpenDNS now? Oh, bummer. I want to get a group together as a user group to basically for feature requests to beat them up.
And I will say,
I'm not bashful.
Request side, so I was in OpenDNS for like a year. We got bought by Cisco in June. We're actually pretty flexible and easy to get things through, but I do need a critical mass of users to kind of help push that over. But our project management team is actually really good. They won't build a feature until like 2 weeks before they commit to a sprint to actually code. So they kind of, like some other projects and different companies I work for, there's a feature request been sitting there for 2 years. And they're like, oh, we're going to build this feature. If the guy who asked for that doesn't even work there anymore, like nobody cares about it, take it off the list. And they're like, no, we committed to it. Just commit later. So if you have a feature, we can get it on the list quickly and we can get it through, but I do need a bunch of people asking for it to justify it.
So.
Jeremy?
We'll work through it. One other thing, just housekeeping, like Nathan said, please come by their booth, come by the Cisco booth this evening, and Rob has the golf event actually set up as well.